Okay, so anyway, of course, this week our class is a continuation of last week's new topic, which is on environmental control technology. Okay, but of course, we are talking in the perspective of energy systems and environment. So even though the topic is not quite, it's really broad. Environmental control, you guys have even have like a few courses covering control technology. So there might be some of the elements that you have already learned, maybe you are familiar with, okay? And that's how learning is. You know, you learn something from different courses and then you apply that into another, right? And that's how it happens in real life as well. So whatever you are learning throughout your 4 years here in your bachelor's degree, okay, you are going to use that wherever, wherever you are, even if you are working, if you are staying at home, okay, if you are continuing your study, always treat knowledge as something that is valuable, okay, that you can definitely use in one way or another, right? So habis lecture hari ni, dari Shala, it's good to have this kan. So anyway, last week we did something like this. Okay? So thank you for those who participated. Okay, and this is a safe version. So basically from the power plants, okay, what are the potential waste that is produced from different stages. Okay. And yeah, we have boiler slag and stuff, ash, CO2, mercury, definitely everything. So it's very specific if you look at uh, the operation as a whole, okay, in power plants. The what type of waste is produced is really related to first is what is the particular stage or what is the particular operation, right? And also, what are the components involved? Okay, so for example, if we're talking about coal, kan? So coal is your fuel here, right? And combustion of coal will definitely produce something. Okay, so it's burned because you want to use the energy released from that burning process. Okay, but at the same time, there are waste that is being produced. Okay, but basically, if we're talking about combustion as a process, and if we have coal, macam last week, I give you the example of, barbecue. And if you do any barbecue, okay, your main aim is to eat that barbecue. Okay? So you are sort of cooking the stuff lah. Okay? But what you are burning is basically the coal, or in barbecue in your case is your kayu arang. Okay, so whatever is left, that is the waste kan, that is the C, the carbon materials that are left from the process. Okay, so basically combustion, it falls under oxidation. The oxidation is a chemical process, right? So if you still remember in high school, belajar tentang oxidation and reduction. Oxidation is the loss of electron or the gain of oxygen. It's usually very related, especially if you're talking about redox processes. So there's always going to be oxidation and reduction. But specifically talking about combustion, okay, it's a chemical reaction of oxygen with other substances. Okay, so you definitely will have something, your fuel, right? So you have your fuel here, which is your hydrocarbon, okay? And then definitely you must have oxygen because that is the reaction. Then you will get in a complete combustion, you will get carbon dioxide and water. Okay, but what happens if it's incomplete combustion? So there will be other components that is being produced. Okay, so for example, here is methane, CH4 is methane. Yeah. And then you oxidize this, you combust this, but it proceeds in an incomplete process. Okay, you're going to have this carbon. Okay. So basically, the oxidation processes, it releases heat. So that's why we tend to utilize that heat for whatever purposes that we want. Okay. And this reaction produces considerable volume of exhaust gas along with, okay, depending on the kind of fuel. So that's me, this is important. Okay, a certain amount of residues. So whatever types of residues is being produced depends on the fuel. All right. That's always something that you have to remember lah. Okay. Whatever processes it is, it always depends on the type of fuel. Okay? And then you will know what are the residues. Okay. So in power plants, okay, I always talk about combustion. Right? So remember back, combustion is an oxidation process, and it's you use oxygen, okay, to generate heat, right? So it can be not only in power plants, basically, right? It can also be used in other industrial processes. Okay, for example, heating. Okay, kita tak nampak, we don't really see this, but in the industry, heating is a very, very significant process. Okay, it's used in a lot of different processes, not only in power plants, not only for electricity generation. Okay, of course, in a lot of industries as well, they use heat exchanger. Okay, so heat exchanger, the generation of steam and hot water is also related to combustion. Okay, even if you want to manufacture something, okay, a lot of these materials, they require some sort of combustion. Right? Of course, lastly, if you have incineration, like incineration of waste materials and residues, I don't know if you've ever heard about incinerator. Then that's one way of managing waste. Okay? And incineration as well, it uses these fuels and then you combust that. And if you have something like waste to energy, for example, waste to energy plants, you can use that combustion process and you capture the energy. Okay, and that energy can be used to power up other processes. It's sort of like a circular economy in practice. Okay, I'm sure you've heard a lot about circular economy. People have been talking about that a lot, right? So that's where things fit in sometimes. Okay. So just a little bit more on the combustion. Okay. So in real processes, you have the stoichiometry, right? Remember back just now with this one, okay? This is the stoichiometry. So you can basically calculate, right, how much oxygen you need for a process to proceed in a complete combustion. Okay, I hope you guys can extract that. Okay. But okay, that works in very small scale. For example, if you want to combine something in the lab, okay, and you have very, very limited amount, okay, that's usually sufficient. But imagine you have now a power plant. Okay, it's a very, very big power plant. You are dealing with a lot of materials, okay, not in kgs anymore. This is in tons per second. Okay, so usually the ideal volume that you use from the calculation of stoichiometry, it is not sufficient for complete burning. Because there's always going to be the problem of mixing. Okay, when you go bigger, right, mixing is always a problem, and this insufficient mixing will make the process less efficient than you expected, right? So what happens is that the combustion process must be supplied with excess air, right? Because remember, combustion it uses oxygen, and oxygen, especially if you're talking about very big scale processes, you don't really use pure oxygen. Why? Sebab dia mahal. Okay, it's easier for you to just use air. Okay, so that's why it must be supplied with excess air. Okay, so imagine you already supply the combustion process with air, kan? And thinking about process, that combustion process as a system, okay, what comes in will equal what comes out. Okay, basically, so as you increase the amount of things coming in, your product, of course, is increased. You may get more electricity, for example, but at the same time, you will also get more waste, right? Because you are basically increasing the volume, right? So if excess air volume is too high, okay, so this is a situation. So there's three situations: an ideal situation, okay, and you have too high amount of excess air. And so if excess air volume is too high, combustion temperature is reduced, okay, and you lost actually energy, okay. Whereas if the excess air is too little, you have your fuel, but not all are combusted, okay, and you will have unburned fuel, okay, further reducing the effectiveness of your combustion process. Okay, so if you look in this figure, so here is the region where it's optimum volume of excess air. Okay, so you want to be in the middle where it's not too much, it's not too little. Okay, that is always the ideal situation. And that is something to be studied in more detail. So it's not, it's not under your purview. Okay, but if you're interested, then maybe it's worth looking into, right? But it's enough for you guys to know that this sort of situation exists. Okay, so it comes to a point now to, if you guys remember just now, I was saying, the waste, the composition of waste depends on the fuel. Okay, so when we are talking about coal-fired power plants, definitely the fuel is coal. And coal, one of the things with coal is that the compounds or the components are relative to where it is. Okay, so for example, here you have 4 different places where the coal comes from. Okay, and the values are also different. Okay, so you can imagine, especially when we're talking about basically how much ash is being produced. Okay, as you see here, ash, right? And you see also something interesting here, sulfur, okay, nitrogen. So these things, remember, whatever is being produced at the end, okay, the waste characteristic will always depend on the fuel, okay, on the coal. Okay, so just keep that in mind as we go into the next few slides. Okay, so basically, okay, let me quickly look at this first. Okay, so basically here, you have your coal. Just now we talked about coal, kan? Right? But what comes in next is basically the boiler, right? So boiler, or some references also call it furnace. Okay, so here in the boiler is where the combustion process is happening, right? And we come to this bit. Okay, so imagine you have your boiler here. Okay, you put in your coal, okay, you put in your air, right? And then from here already you can see a few types of waste being produced. Okay, so as the combustion happen, okay, remember just now we are talking about the possibility of having unburned fuel, and or the whatever the residues that remains after the combustion process. Okay, so first things first is we see here is the bottom ash and boiler slag. Okay, so this is the boiler. Okay, and usually boiler they are called bottom boiler. Okay, these bottom boilers are usually used in the power plants, right? That's why you have this bottom ash. Okay. So bottom ash is when the coal is burned. Okay, the unburned material contains around 80% fly ash and 20% bottom ash. Okay, and bottom ash ni, it looks like this. Okay, it's a dark gray, granular, porous, predominantly sand-sized material, right? Whereas you will also find boiler slag. Okay, but basically, it's either. It can be bottom ash or boiler slag. So um, what is the thing that decides that is whether what type of boiler it is. So if it's a dry boiler, okay, you will get bottom ash here. But if it's a wet boiler, you will get boiler slag. Okay, and boiler slag looks like this. Quite weird, okay, but bear with me. Boiler slag, so usually the ash, okay, whatever uh, is unburned, it contains 20 to 50% fly ash, and the remaining is boiler slag. Okay, so if we just look at that lah, the bottom ash here, kalau if it's a dry boiler, okay, so about 80% fly ash is produced. Whereas if it's a wet boiler, okay, it can be between 20 to 50, right? But usually bottom ash, people currently, okay, a lot of the power plants are using dry boiler, okay, and that's why a lot of the waste is dry boiler, bottom ash, and also fly ash, okay. But if wet boiler is used, then you can get boiler slag, and boiler slag ni is very pretty to look at. Okay, it's even called Black Beauty. And Black Beauty, it's a coarse, hard, angular, glassy material. So you look at that. Okay? Very, very nice, some sort of crystal. Then, so what happened is because during the combustion process, you imagine that underneath here, okay, when the coal comes in, it's a very, very hot place, and it is in a molten kind of state. So can you imagine molten coal? So imagine lava or magma, okay, something like that. It's very, very hot, And then when it comes to a point, okay, they will open underneath here to release the the waste. Okay, so that is in the form of liquid, but underneath here will be quenching liquid. Okay, because they want to make sure that they get everything from here. Okay, so when that molten ash goes into the liquid, fractures, it crystallizes, forms pellets. That's why it looks like this. It looks like crystals. So that's basically two of the things first being produced. Okay, but if you see here, that's fly ash. And fly ash is basically the most being produced. Okay. And of course, remember last week I talked about flue gas. Okay. So usually, right, so this figure, it splits these two. So it has gas here and has another outlet saying that gas and fly ash. But in theory, or rather in real life, okay, there's only one, this is both mixed together, right? But I just want to show you what happens next, right? But remember, whatever comes out of the boiler is called flue gas. Okay? I mean the gas portion. Okay, so you have this gas and fly ash tadi. Okay, it goes into here, okay, electrostatic precipitator or baghouse, right? So what happens here is, you know, as the combustion happens, okay, you know, fly ash will be formed, it will be produced, and it is composed of particulates, right? And it's driven out of the boilers together with the flue gases. And also depends on the coal again. Okay, the components will vary, right? So here are the potential components. Okay, you have substantial amounts, and one more is minor constituents. Okay, but just look first at the substantial amounts that is being produced. Okay, we have silicon dioxide, aluminium oxide, and calcium oxide. So these are produced in excess. Okay. Sorry. And then also we have minor constituents. So these are in trace amounts, but they usually contain very sorry guys, toxic amounts. Sorry, not toxic amounts, toxic components. Okay, arsenic, cadmium, chromium. There's a lot of different toxins in there. Right? Which means that you have to treat this fly ash. You cannot just release it to the environment. Okay, so that's how, so in this situation, so usually it's electrostatic precipitator or baghouse is being used, right? So we'll just go very briefly on, you know, what are the technologies usually used here. Okay, I know that I've mentioned, so in this figure, it already mentioned electrostatic precipitator and baghouse, but we'll just look at how those things work. Okay, just very quickly. So first we have centrifugal separator. So apart from the two mentioned before, okay, this is also one potential way to treat it. Okay, and basically it's using cyclone, right? So imagine you have a device which is turning. Okay, cyclone, if you know, if you just Google cyclone, okay, it can be macam puting beliung tu. Kan? So you can imagine it's something that is moving circular, okay, berpusing. So what happened is that, you know, the particles will be propelled to outside of the gas stream. So usually if you have something like this, so the gas goes from here, right? And, you know, the particles will eventually go down, okay? And the gas will go up, right? So that's how it separates the particulate matters, okay? Primarily fly ash from the gas, okay? Because, you know, you have a lot of different things there. Okay? Right. So apart from that, apart from cyclone, of course, we have electrostatic precipitators. Okay? Electrostatic precipitators are devices where you have electrical field, basically, right? And, you know, So why do people use microfiber cloth, white stuff? Okay, because you say that it does have, it has a charge. Okay, and that's how electrostatic precipitators work. So when the gas stream goes through the electrostatic precipitator, okay, the electric field will give charges to this particulate. They're very, very small particulate. So when they are charged, it's easy for them to be collected, okay, by an electrode. Okay, just remember, positive and negative charges, they attract each other. Yeah, so that's the easiest way to remember about this. Okay, so EP is very, very widely used in power stations. And not only that, in cement plants, in metallurgical plants, and etc. Whenever they have flue gases, okay, electrostatic precipitators will usually be used. Right. Let's go to the next first. Okay. So the third one, we have fabric filters. Okay, just now it's mentioned bag houses. It can be that. Okay, it can also be different forms as well. It can be food as bag. Okay, so but usually it's made from fabrics and they remove particulate matter from the gas stream by retention of the particles. Okay, so imagine you have your gas going here. Okay, and the bags, it has a porous structure. Okay, so imagine you have your water filter. If you ever open your water filter, dalam tu, it has something that is porous. So, whenever things go through, other than, the bigger sizes ones will be collected there. Okay, and it's the same principle here. Okay, it has porosity in here. And lastly, you get your clean gas outlet. So that goes out. And whatever is in the gas before is retained inside. So usually the particulates lah, right? This doesn't cover things that are bonded to the gases. Okay? So anything that is also in gas form cannot be treated using particulate matter control. Okay? Right. So that is about fly ash. Okay. But at the same time, remember just now we have this outlet as well, which I call flue gas. Okay. So if you look in the figure, so it's mainly CO2, water, SOx and NOx. Okay. So just bear with me 1 second. Because I want you guys to do something. Okay, I hope you're all still there. So if you check it out, right, you can do this. Okay, so why do we need to remove sulfur oxides from the flue gas? Kenapa? Okay, you can just use if you're on your phone, you can do that. If you are on your computer, okay, you can do that as well. Come on guys, ada 2 orang. I just saw only 2 people now voted. Okay. Come on, take your time.
Salah tak apa kan, doktor?
Tak apa. Just to make sure you are still awake.
Awake.
Awake. Okay, come on guys. Paruh lagi ni. Lagi pun nak tengok. Kadang-kadang ada yang on je kan. Right, come on. Lagi 7 orang ni. It's anonymous here, so I won't know who didn't vote. So, lagi 5 orang lagi. Oh, by the way, did you see the result? Tak nampak lagi kan? Just checking. Lepas korang jawab, did you see the results as well?
No.
Tak,
No,
Doktor.
Okay, just checking. Okay, so I think more than half already answers. Okay, nampak tak? Result. So most of you guys answered acid rain. So congratulations, betul lah tu. Okay. But also correct buildings and pins is also correct as well, because that also comes from acid rain. Okay. Deforestation as well. Okay, so for this one, it actually has 3 answers. Okay. So just checking. Tengok korang ada ke tak. Yeah. So anyway, sulfur. So we know, you guys know already why sulfur is bad for the environment. And so it means that, you know, it has to be removed from the flue gas. Okay, because imagine this is being produced in tons per day. And so we cannot just release that to the environment. Okay. So in general, 90% or more of the sulfur in the fuel will be found as sulfur oxide. So you can imagine. Okay. So usually what happens is people in the power industry, okay, have developed FGD. So FGD is flue gas desulfurization technologies. Okay, and this type of technologies are used to remove salt, okay, from the flue gases, right? And also it doesn't have to be in power plants as well. You know, we've talked about previously how other industries produce salt as well. Okay, and it depends on the fuel. Okay, so whatever is using coal or other types of fossil fuels that have sulfur in their chemical constituents, then eventually sulfur will be produced as salt. Okay, so you see here it's scrubber. Yeah, so scrubber is one of the ways, and it's most widely used. Okay, if we're talking about FGD, right? And generally with scrubbing, okay, you can remove up to 95% of SO2 from the flue gas. Okay, so it's quite an effective process, right? And in scrubbers, right, so basically it's, you imagine you have an absorbent. Okay, so usually in wet scrubber process, you can use ammonia or you can use sodium sulfide. But usually, if you look here as well, CaO, so people usually use lime or limestone slurry because that is quite cheap. You can get that very, very easily. Okay, so whatever is used, it must be effective lah. So that is one of the reason to select, okay, to choose between the different types of absorbents, right? But basically, if you look here, you have your flue gas coming in. Sorry, it's here. Okay, flue gas comes in, and you have your absorbents in liquid. Okay, and that is dispersed through the scrubber. Okay, so usually it's it goes through sprayer lah. So you look here, di nampak bentuk macam tu kan. So it's sprayed out, okay, and flue gas from below, okay, and that contact between liquid and gas will assist the process. So what happens is that the absorber will bind with the sulfur. Okay? Sulfur oxides can be dioxide. Okay? So it will bind to that, and eventually you get the flue gas clean. Okay? Clean from the sulfur, so from salts. Okay? And this system as well, okay, you will be able to get gypsum. And gypsum, some might call it waste. True, it is, in a way, it's some form of waste you get from this situation. But gypsum is actually quite, you can sell that. Okay, it's very, very valuable. Okay, usually it's used in the, with cements or, the building industry. Okay, so that's one way, okay, where, you can treat the waste of something, okay, and use that as resources in another type of industry. And that is the embodiment of circular economy, okay, where one waste becomes a resource. Okay. And then, of course, let's say management of coal combustion products. Okay, so usually, what is used basically is underneath here. So it's disposal, which is the least preferred, but that is also the cheapest. Okay, so you can see that a lot of ways to treat this, the autumn ash, the boiler slag, okay, and whatever else is being produced from the ash, okay, it goes to landfills or to ash lagoons, right? So, for example, in the UK, currently 50 million tons is of coal ash. So coal ash here means all of them. Okay, so it's the combination between fly ash, bottom ash, and boiler slag. Okay, and it's collectively known as coal ash. So coal ash, 50 million tons, banyak tu. Okay, it's currently stored in landfills. Okay, and in the US, same thing. 23 you have 53 million tons generated in 2013. Yeah, I know that is like 8 years back. Okay, but you can imagine from 53 million, okay, only 23 million is being reused, while the remaining is sent to landfills, right? And also, but there are differences. Okay, some countries does have very, very strict regulation. For example, in the Netherlands, 100% is recycled because they have the regulation of, they don't have landfills. Okay, so whatever is being produced, they have to recycle it. Right? Whereas in Germany, 97% is reused, okay, while the rest is stored temporarily. Okay? So we have like two extremes. We have one where the least preferred way of treatment is being used, okay, because it's the cheapest, it's the easiest. But we also have one where, that's the best kind of situation, okay, where you don't actually have the waste anymore. Okay. So in summary, okay, just looking at this, we have, of course, we're talking about ash tadi kan. So ash, the bottom ash ke boiler slag, it goes to ash pond, right? And also when you have the electrostatic precipitation, then or the fabric filter, you get the fly ash. Okay, fly ash pond goes into the ash pond, right? And then next, you have this fabric filter. Okay, so just very quickly, HG. Siapa tahu HG apa?
Mercury ke doktor?
Yes, betul, mercury. Hebat-hebat. Saya pun lupa hari tu tau. So mercury, remember dalam coal ada mercury tau. Okay, so mercury is, of course, it's very, very toxic, right? And usually in power plants, they use this ACL. So ACI. Okay, ACI is activated carbon injection. Okay, so usually lepas ESP tadi, okay, they have reduced the fly ash tadi kan. So they will inject activated carbon. The activated carbon ni will will attract mercury. Okay, and then it goes again to fabric filter. Then you will get you will be able to reduce the amount of mercury dalam flue gas tadi. Okay, so that also goes to ash pond. Okay, the mercury waste, right? And lastly, you have your FGD. So basically, it can be like this, or some plants also use FGD first. So it depends. Okay, it depends on the design of the plant. All right. Okay. All right. So everything goes to the ash pond. Okay, and you can imagine. Okay, now the regulation is. It used to be just a normal pond, but now people are calling for line pond. So you actually have line here. Sorry, you line it with materials that would not allow any toxic materials to seep into groundwater. Okay, because this is a very, very big issue. So, and then if you have landfills, okay, because apart from ponding, okay, some power plants also has the option to do landfill. Okay, and of course in landfill, you have the leachate, okay, you have the groundwater. Okay, so that is the reality. Of course, many things are used basically to make the situation better. Okay, there are many, many advances. Okay, but this is the current, what is currently happening, right? So basically, in the end of this, okay, after FGD, so last kali yang keluar at your stack is the sort of clean flue gas lah, right? And particularly in Malaysia, unfortunately, we do have the sorry, what is called? We do have a regulation, okay, for specific components. Okay, SOx, NOx, it has its own, but nowadays we are also concerned about CO2, right? And if you remember, CO2 is also very, very significant in flue gas. Okay, but unfortunately in Malaysia, we do not have the regulation against carbon emission. Okay, so I hope it's something that is going to change in the next few years. Okay, but we'll see. But basically, that is the problem, okay, with carbon, because industries they don't have that policy to reduce carbon emission. Okay, of course, talking about that also, these industries are taking their own stand. They are reducing in their own way. Okay, but it's good if they can be incentivized to do so, because the amount of carbon emitted by these industries are very, very significant. Okay. So sorry about that. Whole time again.